This is section 5.9 of Honors Algebra 2, Rational Equations. A rational equation is an equation in which a variable occurs in a denominator. In order to solve it, we're going to essentially need to get it out of the denominator. And so we're going to need to multiply both sides of the equation by the least common denominator, the least common multiple of all the denominators. So whenever we multiply both sides by an expression that contains a variable, we have to be very careful. Because by multiplying by a variable, we could be introducing solutions that are not actual solutions. Numbers that appear to be solutions but are not real solutions. And those are called extraneous solutions. So essentially the lesson is, whenever you're going to multiply both sides by a variable, you need to check your answers and make sure that they work. So let's see an example of a rational equation. Number 1 here. Our task is to solve this equation for x. So we've got 3 over x squared minus 7x plus 10, then plus 2 equals x minus 4 over x minus 5. This is definitely a rational equation because the variable occurs in a denominator. So the way we're going to solve this is to multiply both sides by the least common denominator. That means we need to figure out what the common denominator is, which means we need to factor our denominator. So we factor x squared minus 7x plus 10, and that will factor as x minus 5 times x minus 2. Okay, then we've got a plus 2, which remember is really 2 over 1, so its denominator is 1, equals x minus 4 over x minus 5. So now I can see what the factors of my denominators are. So what's going to be my least common denominator? It's going to be x minus 5 times x minus 2. Okay, so I'm going to multiply everything by that common denominator. Okay, I'll multiply the left side by it and the right side by it. So by x minus 5 times x minus 2, x minus 5 times x minus 2. Alright, so when I'm working on the left side here, if I multiply that fraction by x minus 5 times x minus 2, it just cancels out the denominator that's on the bottom. We just get a 3. Both the x minus 5 and the x minus 2 cancels, which is our goal. We want to get the variables out of the denominator so we can solve it. And we got plus 2 times x minus 5 times x minus 2. Everything needs to get multiplied by the common denominator, including the 2. That equals, on the right side, the x minus 5 will cancel, leaving x minus 4 times x minus 2. We multiply everything by the common denominator, cancel out all the denominators, and then we solve it from there. Okay, so why don't I FOIL out x minus 5 times x minus 2, and I'll get x squared minus 7x plus 10 equals, and x minus 4 times x minus 2, if I FOIL that out, I'll get x squared minus 6x plus 8. Okay, I'll distribute the 2, so 2x squared minus 14x plus 20. I'll bring everything to one side and have 0 on the other side. So I'll subtract the x squared that's on the right over to the left-hand side, and I'll be leaving with just an x squared over there. I'll add the 6x over to the left-hand side. That'll give me negative 8x. I've got 3 and 20 on the left-hand side, so that's 23, and then I'll subtract 8 from that, so that's 15. And that equals 0. Then I factor x squared minus 8x plus 15, now that I have it equal to 0. And that's going to be x minus 5 times x minus 3. So that means that x minus 5 equals 0, or x minus 3 equals 0. So x equals 5, or x equals 3. I need to check for any extraneous solutions, anything that appears to be a solution but is not actually a solution. So if I look back at my original equation, I can notice right away that x cannot be 5, because if x is 5, then this x minus 5 is going to be 0, and I'll be dividing by 0 on the right-hand side. And that is a complete and total problem that I cannot do. I cannot deal with that. So I throw out the option of x being 5. So what about 3? Well, 3 does not make any denominators 0, so that's not a problem. But I should check and make sure that it works. So I can check on x equals 3, and if I plug it in, does the left side equal the right side? So I have 3 over 3 squared is 9 minus 21, then plus 10, and 9 minus 21 is negative 12, plus 10 is negative 2, and plus 2, and 3 over negative 2 is negative 1.5, plus 2 is positive 1/2. On the right hand side I have 3 minus 4, so that's negative 1 over 3 minus 5, which is negative 2, so that's also 1/2. So the left side equals the right side, and x equals 3. That works. So my solution set is simply the set containing the number 3. That's the only solution. 5 is not a solution because 5 makes one of the denominators, actually two of the denominators, 0, and that's a problem. That's undefined. Number 2. Y over y minus 2 minus 2 over y plus 3 equals 10 over y squared plus y minus 6. Okay? Factor the denominators. Well, y minus 2 is already factored. Y plus 3 is already factored. So let's factor y squared plus y minus 6. And beautifully, it factors as y plus 3 times y minus 2, which happen to be the denominators that I have on the left-hand side. Hey. So what is the common denominator? The least common denominator is y plus 3 times y minus 2. So I'm going to multiply everything by that common denominator. Multiply the left side by y plus 3 times y minus 2. Multiply the right side by y plus 3 times y minus 2. Okay, when I multiply that first fraction on the left by y plus 3 times y minus 2, the y minus 2's cancel. So there's a y times a y plus 3. When I multiply the second fraction by it, the y plus 3's cancel. So there's a 2 times y minus 2. On the right-hand side, the whole denominators cancel, and we get 10. Okay, we keep solving. We distribute the y, we get y squared plus 3y. Distribute the negative 2, so we get negative 2y plus 4 equals 10. Combine like terms, y squared plus y, and then we subtract the 10 over, we'll have negative 6 equals 0. And then we factor y squared plus y minus 6. And that will give us y plus 3 times y minus 2, which means y equals negative 3, or y equals 2. Check. Well, y can't be negative 3, because then y plus 3, that denominator would be 0. That's a problem. Y can't be 2, because then this denominator, the y minus 2, would be 0. That's a problem. So what do I do? Well, this means we have no solution. Both of the solutions we found were extraneous, and so they don't work. We throw them out. We have no solution. Number 3, a word problem. One pump can empty the town swimming pool in 7 hours, less time than a smaller second pump can. We've got a large pump that can do it in 7 hours less than the smaller pump. Together they can empty the pool in 12 hours. How much time would it take the larger pump alone to empty it? So the large pump and the small pump together do it in 12 hours. The large pump can do it in 7 hours less time than the smaller pump can. So how long does it take the larger pump to do it? Okay, first step, define a variable. So since we're interested in the larger pump, let's let T be the number of hours for the larger pump to empty the pool alone. Okay? If it does it in 7 hours less than the smaller pump, that means T plus 2 is the number of hours for the smaller pump to empty the pool. Okay? Now I'm going to organize my information. That's my second step. And I'm going to do it in the form of this table. I've got the larger pump and the smaller pump. So how much of the pool, what fraction of the pool, can the larger pump do in 1 hour? If it takes it T hours to do the whole pool, how much can it do in 1 hour? Well, it would do 1 over T. If it takes it 2 hours to do the whole pool, in 1 hour it's going to do half of the pool. If it takes it 3 hours to do the whole pool, in 1 hour it's going to do 1/3 of the pool. So in T hours, it's going to do, if it takes it T hours, it's going to do 1 over T, that fraction of the pool in 1 hour. In 12 hours, it can do 12 times that. So 12 over T, 12 times 1 over T. So we're going to take what we have in this column and multiply it by 12 to get what we have in the right column. If the smaller pump takes T plus 2 hours, sorry, that should be a 7, not a 2. Why didn't you tell me? Why didn't you yell at me and tell me that should be a 7, not a 2? Oh my gosh, I'm so embarrassed. So, if the smaller pump takes T plus 7 hours to empty the pool on its own, how much can it do in 1 hour? Well, in 1 hour, it would do 1 over T plus 7. How much can it do in 12 hours? So we're going to take 1 over T plus 7 and multiply it by 12. That's going to be 12 over T plus 7. Okay? Together, in 12 hours, they empty the whole pool. So in 12 hours, what the larger pump does, which is this box, plus what the smaller pump does, which is this box, equals the whole pool. So here's our equation. 12 over T plus 12 over T plus 7 has to be the whole pool, which is a fraction of 1. The fraction the larger pump does plus the fraction the smaller pump does equals the whole pool, which is 1. Now we're going to solve that equation. So that's our third step. How are we going to solve that equation? Well, we're going to multiply everything in the equation by the common denominator. What's that common denominator? It's going to be T times T plus 7. So I'm going to multiply everything by that, including the right-hand side. Alright, so on the left-hand side, when I multiply 12 over T by T times T plus 7, the T's cancel. We just get 12. I'm going to write this over here, 12 times T plus 7. When I multiply 12 over T plus 7 by T times T plus 7, the T plus 7's cancel, and I just have 12T. On the right-hand side, anything times 1 is just itself, so I just got T times T plus 7, and I'll go ahead and multiply that out, which is T squared plus 7T. Okay, we distribute the 12 on the left-hand side. We'll get 12T plus 7 times 12 is 84, plus 12T equals T squared plus 7T. We bring everything to the left-hand side and combine like terms. So I've got a 12T plus a 12T. That's going to make a 24T. Actually, let's bring everything to the right-hand side so that the T squared is positive. So 0 equals T squared, and 7T minus 24T is negative 17T, and minus 84. So 0 equals T squared minus 17T minus 84. Got it equal to 0, so I factor the other side. And it's going to factor as T plus 4 times T minus 21. That means T equals negative 4. Or T equals 21. Okay, step number 4. Let's answer the question. The question was, how much time would it take the larger pump alone to empty it? And T was the number of hours. So we've got either -4 hours or 21 hours. -4 hours makes no sense at all. They can't go backwards in time. So we'll throw that one out. Does 21 hours work? We can check it. We'd have 12 over 21 plus 12 over 21 plus 7, which is 28. Does that equal 1? And 12 over 21 is the same as 4 sevenths. If we divide everything by 3. Plus 12 over 28 is the same as 3 sevenths. If we divide everything by 4. And 4 sevenths plus 3 sevenths is 7 sevenths, which is 1. So it does equal 1, and it works. So our answer is 21 hours. So 21 is not an extraneous solution. Last problem. Because of strong headwinds, an airplane's ground speed for the first half of a 2,000-kilometer trip averaged only 600 kilometers per hour. What must its ground speed be for the rest of the trip if it is to average 720 kilometers per hour for the entire trip? Let's define a variable. We want to know its ground speed for the rest of the trip. So for the second half. Ground speed, by the way, is its speed relative to the ground. That includes the speed of the plane and the speed of the wind together. That's the ground speed. So we're going to let's call it R, be the ground speed of the plane for the second half. Of the trip. Okay? That's the only variable we're going to need because we know exactly what it did for the first half. Alright? Now the entire trip, as I fill out my chart here, the entire trip was 2,000 kilometers. So half of that is 1,000. That's how far it's going on each half. We remember that distance equals rate times time. That means time equals distance over rate, right? We just solve that equation for time. The rate that is going for the first half is our 600 kilometers. For the second half, that's our R. That's our speed. That's what we're looking for. How fast does it have to go in the second half? So that, overall, it is 720 kilometers per hour. That's what we want the entire trip to be. Okay? Well, if the time is the distance divided by the rate, that means the time for the first half is 1,000 divided by 600, which is 10 over 6, or 5 over 3, so 5/3 of an hour, or 1 2/3 of an hour, or 1 hour and 40 minutes. We'll leave it as 5/3. The second half is going to be the distance, 1,000 divided by the rate, which is R, so 1,000 over R. Okay? The entire trip is going to be its distance, 2,000, divided by its rate, which is 720, and that simplifies to 25 over 9. Okay? Well, the times have to total being what they are for the entire trip. The time for the first half plus the time for the second half has to equal the total time. So we're going to take those times, and we're going to add them together. 5/3 plus 1,000 over R has to be the total time, which is 25 over 9. Okay, we're going to solve that equation. We're going to multiply everything by the common denominator. What's the common denominator? It's going to be 9R. And 9R will cancel all the denominators. So we're going to multiply everything by 9R. 5/3 times 9R, the 3 goes into 9 3 times, leaving you 3R times 5, and that's 15R. 1,000 over R times 9R, the R's cancel, you have 9 times 1,000, which is 9,000, equals 25 over 9 times 9R, the 9's cancel, and you get 25 times R, so 25R. Okay, we bring everything We bring the r's to one side. 9,000 equals 25r minus 15r. That's a 10r. And we divide both sides by 10. And r equals 900. I'll leave you to check your answer. It does work. So we answered the question, and it's 900 kilometers per hour for the second half of the trip. Doing so will give them an average of 720 kilometers per hour. Here are your immediate practice problems. 2 equations. Solve them. Make sure you write down the original problem. And show me all of your work. And check for extraneous solutions. And that is the end of section 5.9.